Welcome everyone to today's webinar, introducing the Ocean Data Platform. Let's see, we have quite a few joined already, but we'll wait a couple of minutes to let everyone sign in. Okay, perhaps we get started. So, welcome to the Getting Started on the Ocean Data Platform Marine Science Edition webinar that we're hosting today. I'm doing this together with my colleague Tom Red, our Ocean Governance Manager, and me speaking is Gustav Kegis, and I'm the Science Director of Hub Ocean. And we also have a number of colleagues from Hub Ocean joining that will be available in the chat today. If you have questions, just have at it this whole webinar. They're there to support. And I want to start by actually thanking Wyomsa for helping us host this webinar and use their channel to reach you all. This all started actually with Arthur Tuda asking us to join the Wyomsa Symposium in Mombasa in September, and he was quite interested in us joining in the ocean data infrastructure conversation, and we set up a special session there, and then this is the first follow-up of that. And so many of you we met down there, and many others have joined from elsewhere. You're all very welcome. So who are we? Hub Ocean, we're a nonprofit dedicated to making ocean data more accessible around the globe for everyone. We're sprung out of Norway, but we have a global view on ocean data, and we also have our sister company Rev Ocean, who's building a fantastic one-of-kind research vessel who's coming into the water in 2027 to start doing research missions. So we will be working also closely with them on our agenda. And we're dedicated to protect and restore the oceans for people and for the ocean. So what this core of what we have built is our ocean data platform. That's what we are centered around. And the platform is what we will give you a good show of today. It is a place where both open data, public and unlocked data sets that we have brought or helped bring to the world meet your own data and private data. And this is happening on a new technology that we have built that is working to make data very fast and accessible and interoperable. And when things are in the data platform, it can be served on many different places, and we will give you kind of a show of that today. There's the more traditional way of working, where you kind of just want to download your data and bring it into maybe your own local machine and put it into your GIS or your data science environment. But it is also a place where the data can be sourced into websites and apps, It's a place where you can work also in other cloud-based environment. We have our own workspaces that we will show today, but you can also work from other data science environments like Google Colab, etc. And then we have GIS integrations where the data can be streamed into GIS. Okay, so a little bit about just before we get started on that, we are also quite dedicated on bringing more data to the world and bringing the industry data to the science world as well. So a couple of examples here showing how we are making more data available. One use case that was one of the first one we had is a company called Aker BioMarine, and they shared fisheries data from almost 15 years, and there's more to come from the Antarctic. And that the kind of data that science doesn't easily gather because it is from every fishing season. And it's actually been some nice publications this year on this data to show predator-prey relationships. And we're having some more science coming. We also have examples of the industry sharing biodiversity observations. So in Brazil, we had industry sharing mammal and turtle observations from their operations, and then we help bring that both to the platform and further into the global repositories such as OBIS. We have also more science use cases where currently we're working and will be working a bit with Basiruta Marine Science Center in Mozambique to help them serve their science data through the platform as another channel for them to get more data and use our technology. And then we also have examples of where we are helping bring new data to this to the ocean community. We have a couple of webinars coming up in December on the new global substrate model that we're collaborating with the DB Seabed on. It's actually already on the platform, but we're going to make a new edition available. So if you're into seabed mapping, on December 11th, we're going to have a great webinar together with our collaborator. Okay, so today, me and Tom, I was going to take you through a little bit of a journey. So we're going to go through the basics of the platform, how to find data, how to explore data, and then how to create your own data collection where you can upload data and collaborate on that data. And then we're going to take you through a little bit of a analysis in different workspaces, and we're going to have a look at GIS integrations as well. And for those who have signed up, that's quite nice because you can spend the time also exploring a bit on the side. But yeah, I would encourage you, if you haven't already, go in on the link and sign up. I think my colleague are putting the link in the chat as well if you want to just push it, because then you can I will show you what you have access to before login and what you get access to when you have logged in. But it's a good opportunity to do that. And then we have a little demo resource page that I will show you in a second that has the essential pieces of what we're showing today, so that you can have that to sort of have a look yourself after the webinar. I did the hard thing of sharing a different screen. We'll see how that works. Let's try this. Okay, excellent. So this is the resource page that we had there. I believe it's in the chat as well. So here you can see a little bit of the different steps, and there's links to create an account, log into the platform, and a couple of hints and tips along the way so you can follow along. When you get to the Ocean Data Platform, this is what meets you. You're not yet signed in, but you have access already to the catalog, and you can already search and see data, but you don't actually have access to the data yet. So here we get all the metadata. I will show you how to search and find things. So you get a first little glimpse of data, but you cannot yet explore it further and export it, but you can at least see it. Now, when you sign in, and it's free to sign in, you just create an account here, you fill in your email address, it sends a little verification code. You don't need to fill in all of these things, just your name and the password. And then you hit register. And now you can sign into the platform. So we'll do that. Now that you're signed in, you have now the ability to explore tables and export data, which means you can get the full data or part of the data down to your local machine. That's one way to access the data. So we go back to the main catalog to have a look at finding data. So when you're here, there are two main ways of finding data. You can use keywords and search, and you can also do a geographic search. So we're actually going to do a little focus today on the Mozambique Channel. So I'm going to zoom into the area around Comoros and Mayotte Island, and I'm going to do a little search box. This means that the data that we're searching for will only be data that covers this area. And because I guess everyone loves coral reefs, we're going to have a little bit of a coral reef theme today. So we're going to start by seeing if there's any coral reef maps in this area. So let's have a look at maybe this coral. Now you're finding, a number of data sets in the catalog that had a hit on coral. And so I recognize a couple here, Allen Coral Atlas, WCMC, I know. We're not at the moment looking at cold water corals, but that's there as well. So let's have a look at this coral reefs from WCMC. So when you get here, you see the sort of extent of that global data set. But we can actually also already start looking what's inside the data set. So there's a little bit of sort of pre-prepared statistics, and I believe Tom will give us a little bit of a throughout example of that in another data set in a bit. But here you can get information about the columns, what's actually in them. In this case, it's not that much, but we can see, for example, that the data covers the start date from 1989 to 2009. We can see how many polygons are generated when. There's also then a number of files in this data set. So when there's files there and they are of PDFs or pictures, you can actually preview them already. So you can hit the little preview button and you can see data. And we can do the same for a PDF, and you can have a report there, and you can perhaps read about that map, how it was created, the classification scheme, and what else. Now, there are two main types of data on the platform. There are files, and that can be anything, like these ones, and they can be data that we support natively on the platform of tabular format, so that's point, polygons, essentially vectorized files. In this case, this map is of that kind. So because it's now ingested in the platform, we can explore that table. And what you see now is the first 1,000 rows that's in that table. It happened to start, actually somewhere way off in the Pacific. We are interested in the Mozambique Channel, so let's go back there, and then we find our area. Again, we're going to be looking around the Comoros today, so I'm going to do a little box here. So now we have done a spatial filter, but we can actually also add additional filters here, like thematic filters or a min-max value. But for this data set, we're quite happy. So we're going to apply those filters. It'll take a little bit of time, but it's actually quite fast considering the size of the data. So now we can actually see quite a lot of this data here. These are 150 polygons in this area with coral reefs. And from here, you can decide to export the data. So we can export as a CSV or a GeoJSON or a Parquet file. Currently, the platform supports natively Parquet and CSV, and we're building that out. So if we want to ingest it to the platform, we can hit Parquet and make it download, and then it downloads what you have filtered, so not that full global data set. Okay, so that's a first show actually of finding one data set, and we've downloaded it. Now we got to bring a little collection, and actually me and Tom are planning to collaborate a bit today. So we're going to leave the catalog for a second. Actually, I'll show you one more thing that I forgot. So when the data is in the catalog, we have two main ways of structuring the data. We have the data sets, but we also have a collection. It doesn't exist for every data set. You don't have to have a collection, but it is a way to group data. And it's up to the data set or the user to say, how are you going to group the data? But here we find all the data from WCMC. We have coral and seagrass data sets. So I'm going to go over to my data section. And of course, I've done a little bit of preparing the ingredients here, but we're going to start a new data collection. And I'm just going to make a very simple test one here because we've populated one to save some time as well. But you can just have a name, a description, and then you've created the collection. The collection, again, is just kind of like a shell. You can add some descriptions, but the main thing is to add the data sets. But I want to invite Tom here, so I'm actually going to do that. Tom, you just got to be an editor on this one. I'm going to be in control. So now Tom can actually see this collection as well, and he can contribute to it. Now, if we saw that data set that I just downloaded, we could decide to if we want to be editing that data, it can be quite convenient to have a copy in our workspace. If we would be in a data science environment, we could pull only the data we wanted directly through our SDK, through the package that talks to the platform. But here we're making an actual physical copy so that we can change it. Let's just call it. So here you can add your metadata, and you can do a number of things. Let's actually start by just uploading the file. This one ended up in my download, so I'm just gonna go and grab that for a second. Let's see how that works. So you can upload that data. Now you've uploaded the file, we could add more files like those PDFs I showed before, supporting documentation, etc. But because it's a tabular format or a vector file, we can actually also ingest it as a table. Now, that means that we can, the data is now in the same format that you just saw in the data catalog. Here we can also edit the table. And if we want to, we can add actually descriptions and make the data look nice. We can make descriptions about the column names if we want, and make it even user friendly if we want to do that. And then of course now it's just a private collection, so maybe it's not so important to fill in all of the things about licenses and citation, but that's all there. And I'm gonna invite my friend Tom again. See. So you have full control who gets to see what inside the data collection. So the other thing that's interesting here to show is we do have all the data sets have an ID. This is how you find the data from anywhere. So we can copy that and reach it from our science workspace, for example. And then for the data that's, we will get to this later, but you also have the ability to request to publish the data in the open catalog. We'll come back to that. And one thing I forgot here, we actually do also have a public sharing link. So if I wanted to make this data available for all of you, I can actually do that. This will be fine. And if you wanted to now have a look for that data, you can. I can even copy that to you and put it in the chat. So this is a way it doesn't become publicly available in the catalog, but it's available for those you share the link with. Okay, so that's one thing. If we wanted to add, let's say, just an Excel spreadsheet with some points in, you can of course do that as well, because we do support CSVs. If we wanted to just do that, we could. I've actually just have a little bounding box for our project area, for example. That's just a lat long coordinates, and you can put that in, and it's just a simple export from Excel to CSV, and that data actually can become a table as well. And we can see that polygon. So if we do that, actually. Okay, so Tom, you know what would be quite nice for our joint collections, which I'm calling the demo project. Now we've got at least one coral reef data set. I was planning to find another couple, but what about protected areas? Could you bring me some protected areas and maybe tell me a little bit about what's in there?
Yep, sure, good stuff. I'm happy to do that. So hello, everybody. My name's Tom. I'm the Ocean Governance Manager here at Hub Ocean. And so today, I'm going to be working with Gustav to try and build out this data collection, which we're thinking of as a mini project. So just whilst I share my screen, I'm going to start from the same landing page, but Gustav has given me a very specific task to do, which is to find data on marine protected areas in the Ocean Data Platform. So for this, I would head over to the public catalog where we can find lots of different data sets. And Gustav already showed some of the coral reef data, but there are many, many other data sets in there. I'm actually, I'm going to look for marine protected areas data. And there's a huge number here. There's EMODnet human activities data here, which also contains WDPA data sets. But I also see this other data collection here, which is called Protected Seas Navigator. And Protected Seas Navigator, for people who don't know it, is a really interesting and comprehensive effort to collect data on marine protected areas at a global level. And what makes the Navigator approach quite unique and interesting is that they actually go into national legislation looking at the exact details of why a marine protected area was set up and what it's set up to protect, and some additional parameters about it. And so we have a partnership with Protected Seas, and which means that we have a live pipeline to their data, which means that it's always updated on Ocean Data Platform. We have two data sets in this collection. One is the complete global database, and the other one is something that we've curated, which is a more focused area-based protections. And I'll just click into that one because that's the one that's actually a little bit more interesting. And here in the metadata, you can actually see what it is that we've done to make this more of a focused data set. So it's very transparent that the changes that we've made. One is we've removed we've removed two categories. One is jurisdictional authority area, and the other are fisheries management areas. The jurisdictional authority areas are things like EEZs, and so typically they're not considered marine protected areas or area-based protection. A similar thing with fisheries management areas. So if you did want both of those, you'd probably want to go to the global data set. But for us, because we're looking at area-based protections, we're going to use this more focused data set. So just to run through a few things that Gustav mentioned. Each of the data sets in the public catalog have a lot of rich metadata. So here, for example, you can see the citation if you wanted to use this data in a project. There's also a number of different other metadata tags, so things like documentation leading back to the original source, in this case, the Protected Seas Navigator website, the methodology that the team at Protected Seas used to develop this data set, and also the data attributes page. There's also a license, so telling you how you can or can't use this data. In this case, it's CC BY, which means that it's open for effectively any use. And actually here we also have a custom metadata tag, which is to say that this is a subset of another data set. So it's quite easy to track back. Each of the data sets in ODP has an API unique identifier, and I'll come on to that in a little bit. For now, I'm not going to worry about doing any programming because I'm going to try and do as much as possible through the web interface. So here we can see within Protected Seas, and Gustav already talked a little bit about this, there are 87 different columns of information about Protected Seas Navigator data, and there are around 20,000 rows. So it's quite a big and comprehensive data set. The columns have a lot of things like the unique identifier for a site, the site name, the country in which it sits, the designation. Really an interesting one, obviously, is the geometry. So then if you wanted to see the exact shape of that marine protected area, this is quite a small one in Florida, but you can actually go and you can see the geometry here. I'm not going to go through the full 87 list. All I would point out is that there are some things like restrictions, which is what can't be done in the marine protected area, and an allowed list of things that can be done. Again, interesting for understanding the purpose of that site. There are links to the underlying regulations. So that's what makes this data set a really interesting and unique data set, is that you can actually go back and really track back the lineage of these protected areas. Then there's a huge number of other interesting features, which I'm not going to talk about too much. Another one that I would highlight is this species of concern, which are species that the protected area was designed to protect, and then some other things like the year that it was established. And you can see here that we have statistics on the entire data set of protected seas, which is showing you, in this case, the range in which these protected areas have been established. There's also another column. Again, it's an interesting one because this is something that Protected Seas developed, the level of fishing protection, which is scoring each of the areas on their level of fishing protection, which is quite an interesting parameter to look at. So 5 is high level of fishing protection and 1 is low. So Gustav asked me to get some data from the study site, and to do that I'll need to go in and explore the data. It loads quite quickly, which is nice because this is actually really quite a big complex data set. And one of the questions in the chat was, how do we search using the map? And in this case, we're going to use the geometry column, and we're going to click on that filter button here. And Gustav gave me the site for where we're looking at studying. So I'm actually just going to zoom in around the Comoros Islands and just click to make a bounding box. And here we go. We can make our bounding box. Once we have that, we can click on refine location and then apply filters. And what it will do now is query through the entire Protected Seas data set and give us only the areas of protection within that study area. And we can see here that we have 9, and that's interesting. And we can then, this is a much more manageable data set. From here, actually, we're going to save this into our private data collection, so we have a much more focused site. As Gustav said, it's quite easy that you can then export the data into a Parquet, a CSV, or a GeoJSON, and we'll come back to that. So I've actually already done this to save a little bit of time. I've uploaded this into the data collection. So this is our project demo for today. And here we have the Protected Seas Areas study site. And this is on the sort of the more admin side. So here again, I can manage the access. I already gave Gustav editorial access. I can give other people viewing access, or I can share this link publicly, so I could share it in the chat today. I'm not going to do that right now. Well, maybe I will. Then if anybody wants to follow along and have a look at this, then I can just pop this in Teams and you can click and you can have access to it now. Let's just do that and see if that works. So then we can preview how that data set would look like in the public, in the sort of the public facing side, or in a sort of more easy to consume format. And here you can see we've got the statistics populated on the data set. This is a small data set, but interestingly, you can see, for example, the years that these MPAs were established. You can see the sort of the range. So you get some indications. And for now, I think, Gustav, that's everything that you required of me. But just one thing that I also wanted to show whilst I remember it, one of the new features of ODP that we've started to implement is an vector tile API, which means that any data set that has a geospatial component can be displayed on a map like this using vector tiles. And you can see here that this is the entirety of the protected seas data set. It actually looks like it's already loaded all of the data in the study area, but if I were to just zoom to another area, all of this data is being loaded in real time. So we're sort of getting quite quick access to data using this vector tiles. And of course, this could be embedded within a website. If you had a subset of data that you wanted to embed in your own website using a vector tiles, then this is something that we would like to enable. And that's just something that I wanted to show that was a little something extra, and be really interesting to hear in the chat if anybody would be interested in using this feature. As I say, it's a relatively new feature, something that we would like to see how it could be used. So Gustav, I think you have from me everything that you asked for. Study sites, marine protected areas in the study site. Let me know if there's anything else you need.
Perfect. Thank you, Tom. And I can actually see I've got that now. Fantastic. Great. So, we're not going to go too deep today, but I wanted to show. So now we have actually our collection is becoming a bit more complete. Me and Tom are collaborating. Whilst you were away, I actually grabbed also Alan Cora Atlas. Alan Cora Atlas is actually an amazingly large data set. It's 40 million rows with geometries, but they are now indexed and optimized on the platform. And here you can also see this kind of pre-compute. You can see pre-computed statistics. You can see that the most common polygon in their map is sand, followed by coral and algae. And I've done, and here's actually the raw files if you for some reason wanted their original files. And we can go all the way down. There's also some documentation here. But I took this, I cropped it just like before, and I put it in my collection. We can find it here. I actually also, this is the admin page of your My Data space, I should say. And to actually see the data, you go to this place where I also put, again, the report for that map. We can see the classification scheme. I've got two maps. I've got my coral, I got my protected area data. Okay, what next? Let's actually start and have a look at it together for a start. So we have a few options when we want to look at the data. We can download it and we can bring it into our GIS or wherever you want to work. So that all works. We also, and we have different ways of connecting to the data. We have our workspaces that we support. And the workspaces is a Jupyter Lab environment. Jupyter Lab, it means, there's a bunch of open source packages. The main one we support is Python, but we're also now working on an R way of connecting to the data. And then there's a beta version of a GIS system. So I'm actually going to play with that a bit today because I like JS and I like to stay actually in the cloud if I can. So I've done a little bit of a let's see, I made something for the demo. I created already a little JS thing here in the cloud. So here we can actually see those data sets together. We see the data that Tom shared with me, the protected the MPA data. We see the two coral maps and we can zoom in on them. Because I'm quite a nerdy coral mapper and I like coral reefs, I do know that there's quite a lot of limitations to this data. So I actually called up a friend of mine, Rudolf, that has done some mapping here, and Rudolf de Villers. So I asked him if we could find another map to bring in, and he said, yes, of course, we have another map. I have a shapefile. So what do we do with that shapefile? So we went back, let's go back to our collection, and let's see. Let's go back to our collection, and not, I put it here. I actually got hold of his data, which was sitting at Iframir. We can even have a look at that. Let's open it in a new window. And yeah, I think very classical. You have one place where there's a map sitting, and it's in a shapefile. It's not necessarily cloud ready, but it had a bunch of metadata. So I went in and I copied and pasted the metadata and checked with my friend. I gave him access. So Rudolf is a user of the platform. He can have an access and he could go in and check that I actually filled in this metadata. Okay. I created the bounding box for the map, and we also put in the time range for that data. To actually upload it so it becomes a table, which I've pre-made here, you need to do a little bit of work with that shapefile currently. So there are two ways of doing that. You can go into your, for example, your GIS environment, and you can export it as a Parquet or CSV, which is one way of then uploading the data, or you can do it in a science environment. So this is the source page. Let's see. So what I actually did for that, I went in here and I did a little bit of work on this data. I created first this data set that I've already shown you how to create a data set, and you copy the ID to that data, and then we in this case, we uploaded the shapefile. We converted that shapefile. I had a look what it looks like. It's in French. I'm not so good at French, so I actually copied the classification scheme and had a ChatGPT translate it to English, so I understood what it meant. And then in the end of this little conversion, we do push it back programmatically to the collection that we made. This is one way to do it if you're somebody who likes data science and you want to have control and a little bit more repeatability. By the end of it, I also stored my notebook so we can get the lineage exactly what happened. Okay, so this is what I've already done for you, and now we can go and explore that table. And here's another map. Again, it's quite a large map actually. So it has lots and lots of small polygons in it. Now, again, there are two ways of bringing this data together. We can put it into our local JS, or we can bring it in to that cloud environment. Let me go back to actually. I'm gonna stop sharing this and go to the GIS so I can show you what it looks like. I think I will just show my whole screen. So now we are in QGIS, an open source JS system, but you could have been in ArcGIS as well. This is now actually the map. I'm not sure if Rudolf would approve my coloring of this map, but this is the shapefile that I downloaded from the platform, and I just put it here. And the same thing with those other data sets that we cropped. WCMC data looks like this. Alan Coral Atlas looks like this. So there are 3 different maps here. Which one should I actually go for? And I could also do a filtering and only look at, which is the case I did for Alan Coral Atlas. I just exported the coral reef polygons, but still it's quite a lot. And I will come back to what we can do already with support of the platform to create uniform maps, because it's not trivial work, and it can be quite tricky with different mapping units and scales. Okay, and then we had the data set from Tom. Now, Tom, not to discredit your effort, but there is another way to show actually that protected seas data here in QGIS. And that's because QGIS supports something that's called OGC features. It's a new it's a new way of streaming data into GIS that's fairly efficient. The Ocean Data Catalog exposes OGC features wherever it's possible for the data to GIS. So here you can find the whole data catalog, and let's see if I can actually go and find that data. We can then just drag and drop the Protected Seas Navigator, and that brings the whole data set in, focused on where you are. It doesn't bring the whole data in, it brings the data into where you are. So now we can actually go and have a look at those polygons as well. So yet this is another way of connecting to the data. Okay, so we're gonna go back to, we're gonna go back to our science environment for a second. Tom, did you want to do any more advanced science, or how you're feeling today on time?
I think we could. I think you've showed everything. Good stuff. There's one thing that I think you could show maybe with this really nice data set uh, on coral reefs, and that's how somebody might, if they wanted to publish that to the public catalog. So far you've showed everybody how you can share it between colleagues. But if somebody wanted to publish their own data set so that it was available to everybody and findable in the catalog, how would you do that?
Very good point. Okay, so actually, Rudolph already approved that, and he's not on the call, what I could see. But what you do when this is happy and everyone's happy, you've got the main things to get in is ensuring you have the license and the source right, and the okay, of course, of the original source of the data. Then you can hit the request to publish. What happens then is that we will just review that those basic requirements are fulfilled. And when that looks good, we will publish it on the catalog. And if there's any questions, we will come back to you. Now, I'm actually going to let Rudolph do this himself because I think that's a better practice. So I'm not going to hit OK. But that's how simple it is once you have the data lined up. Okay, so I want to go to what we can actually do with those maps. So again, now we're back into the science environment that we have. When you have many polygons, you can actually use one of the features through our SDK, which is called aggregations. This is nothing I'm going to demo today. I'm just going to talk you through what it is. I will show you an example how we used it. Aggregations is some of the server-side compute that we support. So through the SDK and you have all the documentation, how it works here on the documentation. So you can go through the Python and our SDK. It will take you through all the functions. This is something we're very happy to do a more focused workshop on at a later date. Through here, you can actually aggregate data on the server side, which means you don't need to access it first and use the compute in your science environment. And then you can say, and it has support for something called H3 tiles, which is a a global way of tiling up the planet into small units that's hierarchical. So we can have a look there. Is there a coral reef polygon in our area and in any of these maps regarding of the classification scheme? I see we have a question online. Maybe we do that first. Samantha, would you wanna? You raised your hand. Maybe that's okay. Put it in the chat or raise or just interrupt me and we address your question. Okay, what it then can look like, I will show you just an example of something we have built. This is an example of the same area without that extra map actually. But here are those Allen Coral Atlas and the WCMC coral polygons. And then we've aggregated just a presence. And there are many ways of aggregating data, but just a presence of a fairly coarse resolution here of hexagons. So the green means that one of the maps were showing coral reef in them. And then we put that together in a little web app. We also actually did the uncertainty where we thought there could be corals, but they weren't in the map because the map was missing. But yet again, this is kind of a little nice visualization that you can create on top of the platform. And that you can do, of course, with many different kind of maps for many different purposes. I think that's all I wanted to say about this part. So I think we are essentially stopping here today. We've created a collection. We brought lots of data together. We're sort of well set up now to do some more advanced science together in different environments, and we can visualize them and we can publish results. And I think with that, we will open up for some questions. I'm sure there are plenty already. And we will also do a little poll to see what you kind of want and need. But maybe we'll just do a few questions first. See, Tom, did you find anyone in the chat? I've been a little bit slow to follow.
I don't think we have any questions in the chat, but Samantha, I still see you had your hand up, and I did see you unmute. So if you're able to unmute now and you wanted to ask a question, then please feel free. If not, Gustav, you could put one of the polls in the chat.
Yeah, let's do that. I see G. Lee had a question about the polygons on the map, but I assume it was resolved. But if not, give it a shout and we can do another show of that. Okay, polls. Let's we have just 4 questions to understand a bit what you thought about the webinar and also looking forward how we can support you better from our side. So we'll start with the first little easy one. If you can just describe this webinar with a word, just your first reaction. And actually, these polls stay open as well. So if you don't come up with a great word now, you are free to go back to them and put in a word if you want in a bit. And okay, I think we move on with the next one. So we're gonna ask you what part of the webinar was most useful to you, and I think of the features that you are most interested in your work. So the Ocean Data Platform, just the ability to find data, explore data on the platform, what's already there, your own data space, a way to manage your data, and collaborate on data. The analysis part where you can use the Ocean Data Platform through Python and R, visualizing data in your GIS and share data to the catalog and expose it to others.
Gustav,
Mm-hmm.
there are a couple of really good questions in the chat
Great.
about creating API keys. Would you mind if I just shared my screen whilst people are filling out the poll so I can answer both those questions?
Yeah, perfect.
Yeah. Okay, so let me just share my screen. So there were two questions, one from Rangvold and one from G again. One is on if somebody's creating an app using data that's on ODP, whether they would need to use their own API key or whether other people would need to have their own API key to access that data. And then the other one is how do you generate an API key? So I'll try and answer both those questions. So at the moment, the way that we work with ODP and API access is if you're working in the workspace here, you're already automatically authenticated against ODP. So that's like if you're doing programming and you want it the easiest way, the easiest way is to just go into the workspace and then you're straight away authenticated. If you're working outside of ODP, for example, in another coding environment, and I sometimes use Colab because it has Gemini built into it, and I must admit I'm not a great coder, so I use the AI to help me with some coding. Then you need to import your own API token here, and it's the same thing if you were building an app that you wanted to be pulling data from ODP from. So I'm just going to show how you generate an API token, and the answer is at the moment, then if you were creating your own app, then yes, you'd be using your own token, so everybody would be sort of if it's a public facing app, then all of the users would be kind of like using your token for now. But that's something that we're thinking of implementing in a different way, potentially. It's really easy to create an API token. So just from the start, you hover over your account up here, and it gives you this account box. And then you can go in here and create your own API token. And you can see here that I already have two created. At the moment, we have a limit of the two. So I'll just delete that other one and just create a test token. Just give it a name, generate it, and then you've got the API token here that you can copy into whatever environment you're working in. So for me, for example, in this Colab one, I could create a new secret, type in the name, paste in the value, and then it's going to get good to go, and I can start authenticating myself against ODP using that methodology. Hopefully that was clear. If it wasn't, then please feel free to ask again. And also it's a great way of giving us some hints on how we can improve our documentation. So that kind of feedback is really useful.
Yeah, thank you for those questions. I don't see another one at the moment. So while we are thinking about more good questions, I'll just submit you another question to you guys. So describe just sort of your main pain point or your main challenge where you think that Ocean Data Platform could be helpful in a couple of words. I see we have another question, Tom, from Honor Caracas. I'm curious whether you're planning to use this platform for training people in understanding marine data. Are there any initiative already moving in that direction? That's a very timely question for the next poll question that I'm going to bring up. So I'm actually, why don't we just start that? Can have a look first also at the results. Yeah. I guess everyone is saying that data is the main thing and challenge, which makes sense why you are here. That is our main challenge too, and that we're working on to help you with. Okay, let's have a look at just the last question because it's coming to that final point. So, what kind of training or support will be most helpful to you? And we're asking this because in 2026, we're going to do a little deepening series. So today you just got a little bit of a whiff of different pieces of the platform. But both as we're growing and maturing some of the more advanced features, as well as um, yeah, having users who wants to really dive into the science environment, for example, and learning more about how to connect and work with our software development kit, our packages to Python and R, for example. We're going to do a deepening. We're thinking to do a deepening webinar series. There's also the potential to do more handheld training sessions or even courses. So the webinars will happen. The training and more deeper support really depends on what your needs are. So we're very happy to hear from you. Of course, we are also here to support online, and there's documentation and examples. So very helpful if you can fill in what you think, and of course we're very happy to hear from you after the webinar too. I think if there's no more questions, we could actually end up wrapping up about on the hour instead. Before we quit, let me show you just our event calendar so you know what's going on next. We gave us some extra time today just to see if you wanted to have more advanced questions answered. We can spend some time still, but if we are all happy for today, then I think it's all good to end up a little bit early. I would just Samantha, see your hand up. Did you have a question to raise? You have to unmute yourself, and then please speak. Okay, while we're waiting for Samantha, I'm just going to show you the event calendar that's coming next. So next week, we're going to continue a series on together with the data providers. We actually had one earlier this week, and you can find a recording on this event calendar page too, about the protected seas data, a little deep dive in that, and a little shorter intro to the platform. We're going to also have a larger event about a new global substrate model that we're publishing on the platform. It's going to be in 11th of December, and then we are also looking to do more introduction webinars and more data webinars coming up. So we will of course reach out to you when there's something, but you're also welcome to keep an eye on this calendar. And you will find the recording of this webinar and our all webinars here in the bottom of this event page. Okay, so with that, if there's no more questions, I'm very thankful for everyone showing up today, and looking forward to see you on the platform. Please reach out to us if you have any questions. And thank you. Thank you, Tom, as well.
Oh, thank you everyone for joining.
Okay. See you.